In this problem, we want to find all the zeros, all real zeros of this polynomial. But unlike the last problem, we are not given a zero to start with. So we have to find our first zero. Now we certainly don't want to find that zero by randomly guessing, by plugging in various real numbers, because that could take forever. So instead, we want to make educated guesses. One educated guess is that this function has a rational zero. So let's start by looking at our list of possible rational zeros. Recall that the rational zeros, if there are any of this polynomial, must have a numerator that is a factor of 3 and a denominator that is a factor of 2. So the possible rational zeros are plus or minus 1, plus or minus 1/2, plus or minus 3, or plus or minus 3/2. So this is a nice finite list to at least look for a zero for this function. So to find whether or not any of these are zeros, we just plug them in and see if they make the function value equal to 0. So plug in 1, 2 minus 1 is 1, minus 6 is a -5, plus 3 is -2, so 1 is not a 0. Plug in -1, -2, minus 1 is -3, plus 6 is 3, plus another 3 is equal to 6, so -1 is also not a 0. Now to get to these fractions, or in these more complicated expressions, plug it into the polynomial, you might want to use a calculator, or perhaps you want to evaluate the function using synthetic division, which is something that we learned a couple of videos back. So to evaluate the function at 1/2, let's put 1/2 in the box and run through the synthetic division algorithm. Bring the 2 down, multiply and add, multiply and add, multiply and add. We get a remainder of 0, so 1/2 is a 0 of this function. All the other zeros must come from the quotient. 2x squared minus 6 is our quotient. Set it equal to 0 to find the other real zeros. Here, this is easy enough. Move the 6 over, divide by 2. The other 2 zeros are plus or minus radical 3. So we have 1/2, positive radical 3, and a negative radical 3. These are the 3 real zeros for this polynomial.